Welcome back to our series on data handling for statistics. I'm Mark Ledbetter, and this is video 7. So we're going to start with our code here, and we're going to call this Basics 3. I'm going to continue right where I left off last time. If you remember, we're using the datasets package, or we were. I don't think I used that in this video, but we did last time. It's good to remind ourselves that it exists. So last times we talked about the missing values, which are called an NA, and you'll notice how blue they are. And now we're going to look at something called an NaN, capital N, little a, capital N. This is not a number, so that's what it stands for. So in mathematics, there are some undefined or indeterminate, I think is another way, indeterminate values or operations. So 0 divided by 0, what happens? I get NaN, not a number. You can't divide 0 by 0. It can be anything. In calculus, we have some ways of figuring out if there is a value there or not. The same thing is true for infinity divided by infinity. So if I run this, again, I get not a number. Infinity minus infinity, not a number. Now, why? Because infinity plus any number is still infinity, okay? So infinity minus any number is still infinity. So infinity minus infinity can be any number between negative infinity and positive infinity, okay? And then infinity, so I did that one, yeah. So negative infinity divided by negative infinity is still not a number. And positive infinity divided by negative infinity, you get the pattern, not a number. Negative infinity divided by positive infinity, not a number. Okay. Now, R is not always correct. Okay. So 8 divided by 0 is not infinity, it's undefined, but it gives you positive infinity as an answer. It could be positive infinity or negative infinity. It depends on if it's usually by a limit. So if you're approaching from the left, then you're in positive numbers, you're in negative numbers close to 0, and so you'd have negative infinity. If you're approaching from the right, you'd have positive numbers close to 0, and so it goes to positive infinity, okay? But there is no such thing as 8 divided by 0 is not defined, okay? But R still gives you a value. It says it's infinity. So just because R tells you a value, that doesn't mean it's correct. You have to know your math too. Okay? And infinity plus infinity, this is correct. It is infinity. But infinity divided by 0 again is not defined. And so, but R will tell you it's infinity. And as I showed before, infinity plus a million, still infinity. Now, we have something that detects not a number, or NaNs, is.nan, and I'm putting a value in there. And remember, it's saying that this is 0, okay? Which is correct, it is 0, okay? So 0 divided by infinity is 0, so that's a number. So if I run this, it says false. This is not an NaN. If I want to say is.nan, and I say 0 divided by 0, this is true. Okay, so true. Copy this, put it up here. Okay, save. So we've got NAs for missing values, and undefined values are NANs. So these are both problematic if you're trying to do something with the data that has these in there. Okay, so be careful. Those become difficult sometimes to deal with. Now let's go back to vector operations. We've talked about these before. Now I want to go into more depth. So let's remind ourselves what addition and subtraction is. So if I have two vectors of the same length, so they have the same number of elements, and these vectors have 5 elements each, as you can see over here, 1 to 5, 1 to 5, then I can add and subtract these vectors, and what I do is the first element of the first one, I add with the first element of the second one. The second elements of each, the third elements of each go together, etc. So I'm going to highlight both of these and run them. And so if I add 12 and a half and 5, I get 17 and a half. If I subtract 12 and a half minus 5, I get 7 and a half. So you can see, and here they are pasted in. So you can see the values. Now, in math, they have to be the same length in order for us to subtract them. But in R, they do not. So we're going to learn about that. Because it's really important. If you're not careful and you have vectors or matrices that are of different lengths or what have you, then or different dimensions than they should be, sometimes R will go ahead and calculate it for you, and it does something weird that you need to understand. Sometimes we like it and it works in our advantage. We use that to our advantage, and sometimes we don't like it, and so you need to know about it. But before we talk about that, let's talk about multiplication and division. So we're going to talk about multiplication of two vectors or a vector with a constant, the way R does it, okay? Not the way we do it in math. Because in math, we consider them as vectors are a simplified matrix, and so we use matrix operations. But R doesn't do that unless you tell it to. So if I take a constant times a vector, now this is what we do in math. 5 times the vector x, that means I take 5 times each element. So 5 times this vector here, x, means that I take the 5 and multiply it by the first value, the second value, the third value, the fourth value, the fifth value, etc. And 5 times 12 and a half is 62.5. 5 times 4.2 is 21, etc. So here I'm going to actually run it, and sure enough, here are the values it gives me. It takes 5 times each of the values of x, here's x, so you can see, 5 times each of the values and returns that. Now, if we use the operator, the asterisk or multiplication operator for multiplying two vectors, then it's going to multiply the corresponding elements in each vector times each other, okay? Again, in math, this is not something we usually do. So if I take x times x1, what it's doing is x is x is 12.5, 4.2, 2.2, 7.1, and 25.9. Here is x1. If I multiply these this way, then what it's done is it's taken 5 times 12 and a half and given me 62.5. It's taken 8.5 times 4.2 and given me 35.7, etc. So it takes the corresponding elements and multiplies them together. It doesn't do anything else, it just does that, which is fine. Sometimes that's what we want, okay? But now what happens if we try to multiply or add vectors that are not the same length? Well, again, in mathematics, it's not possible, but it is in R. So what I've said here is in reality we cannot. However, R does, but how? What does it do? What's it doing? How's it doing it? It's using something called a recycling rule. Okay, it recycles the elements of some of the vectors. So we have to understand that so that we know what we're getting. Okay, so be careful. Just because you get an answer doesn't mean it's correct. And that is very true in R. Okay, and other programming languages as well. I'm not putting R down. Everybody does it. SAS, which is a very expensive program, does a similar thing. It treats it differently, but it does the same type of thing. Okay, so this is a common occurrence in software. Okay, so the recycling rule: if two vectors of different lengths are added, subtracted, multiplied, divided, etc., or added and subtracted, multiplied, you can't divide vectors, then R uses the length of the longest vector. So that means that it takes any of the shorter vectors and makes them the same length as the longest vector. And in order to do that, it recycles the elements. Of each shorter vector until that vector has the same number of elements as the longest vector. Oh my gosh, what is this saying, right? So let's take an example. if you remember, we can create a new vector by concatenating old vectors. So here's an example. I'm going to take the vector x, 12.5, 4.2, etc. I'm going to take it and I'm going to put it together with the number 1 and with itself. And so they're just going to like stack these on top of each other, okay? Because if you remember, vectors are columns. They are not rows. R prints them out as rows, but it knows in its memory, it treats them as columns. So, and that's how we treat them in math. A vector is a column of numbers, not a row of numbers. Okay, so where x prints this out for efficiency as a row, this is really a column. Okay, so let's make y here, and when I do that, I've got, if I run, so I've copied that up there. The length of y is 11 because x had 5. Then there's one number here, so that's 6 plus 5. So 6 plus 5 is 11. So here are the 11 numbers. So here's x. Okay. Here's, let's see, where'd it go? Let's see. Oh, I'm sorry, I missed it. So here's x. Here's 1. And here's x again. Okay. All right. So we've created this vector here. Now what happens if I want to take 2 times x minus y? Now x only has 5 elements, y has 11, and then, whoops, and then I'm going to add 2 to each element. Okay, so you get this warning message. And if you get this message, you see it's in red, you might think that nothing happened, but look up here in the environment. Here it is. And so if I want to print this out, what is z? Here's z, 14.5, 6.2, etc. And the length of z, of course I can look in the up here and see that it's 11, or it gives me 11 if I type the length. Okay. It says the longer object length is not a multiple of shorter object length, but it's not about it being a multiple, it's about being equal to, right? So when we look at z and the length, as I've done here, then we see that there's 11 elements. How in the world did it take 5 elements, so 2 times the x vector, which only has 5 elements, subtract 11 elements, and then add a 2 to each of the elements? So let's see in detail what's happening here. So what it does is it starts repeating or recycling the elements of x until it has 11. Since y has 11 elements, I need x to have 11 elements. So what I do is I start with the first element of x and I keep on going until I have 11. Now I've run out of elements after 5. So where do I get the next element? I go back to the first element and I add it. And that's still not 11, so I add the next one. That's still not 11, I keep going. Still not 11, I keep going. Still not 11, I keep going. Now I've run to the end of it again. I still don't have 11. What do? I come back to the first element again and recycle these elements until I have the right number of elements. Okay? So if you remember that z is 2 times x minus y plus 2. Let's see how it does this. So there's the recycled x. Now I have to take a 2 times each of these elements. So here it is. 2 times each of the elements of the recycled x. I subtract y. Now negative y is the same thing as, it's defined as negative 1 times y. These are identical. They're the same thing. That's what negative y is. It's a negative 1 times y. You say minus y, that's really plus a negative 1 times y. Okay? So here is negative y. All right? And then I'm adding a 2. It's a constant. It's not a vector, but I can't add a constant to a vector. So R makes 2 a vector. How does it do that? It makes a vector of 11 2's here, so that we have a 2 that we can add to each element. Okay, so we take 25 minus 12.5, that's 12.5, plus 2, that's 14.5. So Now, because we've recycled the values of x and recycled the values of 2, we can do the operation, even though mathematics would tell you that you can't. R will do it. So you need to understand how this is working so that if it ever happens to you, you understand what you're getting. Sometimes it's garbage because you've made a mistake, and sometimes you may like this feature, and so you can use it to your advantage. Okay? But you have to know about it. All right. So that is the recycling rule in R. Now, I'm not going to go over all these, but here are a list of some common functions that work on vectors, and we've talked about some of these. Here's the sort, okay? Here's the sort decreasing, right? Now, I didn't assign this to anything, I just did it, right? So this is not in memory anywhere. It's just, I had it print out, but I haven't assigned it to anything, so it's not in memory, okay? We've got the max, the min, the range. Look at the range. The range gives you the minimum and the maximum, not the difference between them, okay? The sum adds them all up. The product multiplies them all. Square root takes the square root of each. X squared takes the square of each element. Here's the mean. And I get the mean by taking the sum divided by the length. So that's the exact same value. That's how you calculate a mean. Add up all the values, divide by how many there are. The length of x tells you how many elements are in x, right? Okay, and remember, these are vectors. The log, remember that that's base e, even though it doesn't say ln, it says log. In statistics, our assumption is that we're using the base e of log. And then exp to the x, that's e to the x. Okay, and here's log, taking the log of each element. Here's exp to the x. Sine x, cosine x, tangent x, there's many more. Okay, but they take and operate on every element of the vector. Okay, so I think that's a good stopping place for this video. It's been about 17 minutes or so. So we'll pick up here in the next video. So please make sure that you get your code along file uploaded to Moodle before the deadline, so you can get 100 on it. And please take care of yourself, stay safe, because we want to see you here next time.